Download this code from codegive.com, link in the description below. Diving deep, accessing app game files and data on iOS, with code examples. This tutorial delves into the intricate process of accessing app game files and data on an iOS device. It covers various techniques, considerations, and provides code examples, mostly in Swift, with Objective-C alternatives where appropriate, to help you understand and potentially implement these methods. Important note: accessing app data of apps you do not own is generally prohibited and against Apple's terms of service and carries legal implications. This guide focuses on analyzing your own apps, for debugging, reverse engineering, modding, or educational purposes, or apps that have explicit developer consent. Disclaimer: this tutorial involves potentially sensitive actions. Always respect privacy, adhere to legal guidelines, and understand the risks involved. Use this knowledge responsibly and ethically. Understanding the landscape, security and sandboxing. Before diving into specific methods, it's crucial to understand iOS's security model. Apple implements a robust sandboxing mechanism to isolate apps from each other and the system. This means each app runs in its own container. An app can only directly access files within its own designated directory structure. Limited access to system resources. Access to hardware, example camera, microphone, and other system resources requires explicit user permission. Code signing and app verification. Ensures that only authorized code runs on the device. 2. Accessing your app's files, debugging and development. The simplest and most legitimate way to access your own app's files is during development and debugging. A. Using Xcode's containers. 1. Build and run your app. Deploy your app to a simulator or a physical device connected to Xcode. 2. Access the container. Xcode 11 and later. Go to the Devices and Simulators window, Window-Devices and Simulators, or Command+Shift+2. Select your device, or simulator. In the Installed Apps section, find your app. Click the gear icon next to your app. Select Download Container. This will download a .scap data file. Older Xcode versions. Go to the Debug menu. Debug attach to process. Select your app. In Xcode's debug console, type PO-NS home directory, or XPR-ONS home directory, description for older versions of Xcode, and print NS home directory in Swift LLDB. This will print the path to your app's home directory. Open the path in Finder by copying it and using Go to Folder, Command+Shift+G. 3. Analyze the .scap data file. The .scap data file is actually a package, a directory. Right-click on it and choose Show Package Contents. Inside, you'll find the following important folders. *appdata/documents*. This is where you typically store user-generated data, example saved games, user profiles. *appdata/library/caches*. For temporary files that can be regenerated. *appdata/library/preferences*. Stores your app's user defaults, settings. *appdata/tmp*. Another location for temporary files. *appdata/storekit*. For storekit related information. B. Using File Manager in code***. You can programmatically access and manipulate files within your app's sandbox using File Manager. Objective-C equivalent, for list files. Important notes about File Manager**. Asterisk paths are URLs. Asterisk use URL objects instead of strings for file paths for better safety and compatibility. Asterisk error handling. Asterisk always wrap file operations in do-catch blocks to handle potential errors. Asterisk permissions. Asterisk you might need to request permissions, example for external storage, if you are accessing files outside of your app's sandbox. But this is rare for game data files stored within the app's documents directory. Asterisk atomicity. Asterisk atomically, true in write, to atomically encoding ensures that the entire write operation completes successfully or fails, preventing data corruption if the app crashes during writing. C. Using user defaults. Asterisk asterisk. User defaults is a convenient way to store small amounts of data, preferences, settings, etc. It's automatically persisted and available across app launches. Objective-C equivalent. Asterisk. 3. Analyzing game data, reverse engineering and modding, use with caution. Accessing another app's data is a complex and ethically sensitive topic. It is also against Apple's developer program license agreement unless you have explicit permission from the app's developer. The following techniques are presented for educational purposes only, to understand how iOS apps store data. Applying them to apps you don't own without permission is illegal in many jurisdictions. A. Jailbreaking, not recommended for general use. Jailbreaking removes many of iOS's security restrictions, giving you root access to the file system. This voids your warranty, can make your device unstable, and poses significant security risks. Asterisk how it works. Asterisk jailbreaking exploits vulnerabilities in iOS to bypass security checks. Tools like Checkra1n or UNC0ver, depending on iOS version and device, are typically used. Asterisk accessing files. Asterisk after jailbreaking, you can use tools like iFile, on the device, or SSH, from a computer, to browse the file system and access other apps containers, located in /var/mobile/containers/data/application/. Asterisk ethical and legal concerns. Asterisk jailbreaking and accessing other apps' data without permission is illegal in many countries and violates App Store terms. B. Runtime analysis tools, advanced. These tools allow you to inspect an app's memory, function calls, and file access patterns while it's running. 1. Frida asterisk a dynamic instrumentation toolkit that lets you inject JavaScript snippets into running processes to observe and modify their behavior. Asterisk how it works. Asterisk Frida attaches to a running process and executes JavaScript code within its memory space. You can use it to intercept function calls, read/write memory, and even change the flow of execution. Asterisk example, Frida script, requires Frida iOS dump. Asterisk requirements. Asterisk jailbroken device, generally, Frida installed on your computer and device, and knowledge of reverse engineering techniques to identify the target function. You will likely need to disassemble the app, using tools like Hopper or IDA Pro, to find the function addresses. Asterisk getting started with Frida asterisk. Asterisk install Frida CLI on your computer, pip install Frida tools. Asterisk install Frida server on your jailbroken device, using Cydia or Cilio. Asterisk use Frida PSU, on your computer, to list running processes on the device and verify Frida is working. Asterisk run your script using Frida ufcom example.game_script.js, replace com_example.game with your apps bundle identifier. 2. Cycrypt asterisk a runtime manipulation tool that allows you to interact with running Objective-C applications using JavaScript syntax. Useful for inspecting the object graph and properties. Asterisk how it works. Asterisk Cycrypt injects a JavaScript runtime into the target process. You can then use JavaScript commands to access and modify Objective-C objects. Example requirements jailbroken device, Cycrypt installed, usually through Cydia. Limitations primarily useful for Objective-C applications. Less effective with Swift code. 3 Hopper disassembler / IDA Pro * static analysis tools to disassemble and decompile the app's binary code. This helps understand the app's inner workings and identify key functions and data structures. How it works * These tools analyze the compiled machine code of the app and convert it into assembly language or, in some cases, a higher level representation, pseudocode. Use cases finding function addresses for Frida injection, understanding the logic of save game mechanisms, identifying encryption algorithms used to protect data. Requirements the app's IPA file, which you can get from your own apps, or through other methods, ethical considerations apply, Hopper or IDA Pro installed on your computer. Complexity requires significant reverse engineering skills to understand disassembled code. C. Binary patching, extremely advanced and risky. Binary patching involves modifying the executable code of the app directly. This is used to change the app's behavior, bypass security checks, or cheat in games. This is highly unethical and illegal without permission from the app developer. It is extremely dangerous and can brick your device or cause instability. How it works after disassembling the app and identifying the code you want to modify, you use a hex editor to change the bytes of the executable file. You must then resign the application so it can run on the device. Example, highly simplified. Let's say you found a line of assembly code that subtracts 10 points from the player's score. You could change the subtraction instruction to an addition instruction, or change the amount subtracted to 0, effectively disabling the score deduction. Requirements jailbroken device, deep knowledge of assembly language and iOS internals, hex editor, code signing tools. Risks very high risk of breaking the app or the device. Requires significant expertise. 4. Dealing with encryption and obfuscation. Game developers often use encryption and obfuscation to protect their data and code. Encryption game data, save files, assets, etc., may be encrypted to prevent tampering. You'll need to find the encryption key and algorithm to decrypt the data. This often involves reverse engineering the app's code to identify the encryption routines. Obfuscation code obfuscation makes the app's code harder to read and understand. Techniques include renaming variables and functions to meaningless names. Inserting dead code. Using control flow obfuscation, making the code jump around in a confusing way. String encryption encrypting strings within the code to make them harder to find using simple string searches. Overcoming these challenges requires advanced reverse engineering skills and the use of tools like Hopper and IDA Pro to analyze the app's code. Deobfuscation and decryption are often the most difficult parts of reverse engineering. Practical considerations and ethical boundaries. Legality accessing another app's data without permission is illegal in many jurisdictions. Ethical concerns respect privacy and intellectual property rights. Terms of service violating App Store terms can lead to account suspension. Device stability jailbreaking and binary patching can make your device unstable. Security risks jailbreaking exposes your device to security threats. Focus on your own apps the most legitimate and safe way to explore app data is within your own development projects. 6. Alternatives to direct data access, formatting, where possible. Game modding APIs, if available. Some games provide official modding APIs or scripting interfaces that allow you to modify the game's behavior in a controlled and authorized way. In-app purchases, ethical, legal. If you want to modify the game experience, consider purchasing in-app items or features that are designed to enhance gameplay. This is the most ethical and legal way to support the game developer. Reverse engineering for educational purposes, carefully study the game's behavior, memory usage, and network communication to learn about game development techniques. But avoid actually modifying the game or sharing your findings publicly if it violates the game's terms of service. 7. Conclusion. Accessing app game files and data on iOS is a complex and multifaceted topic. While there are legitimate uses, debugging, development, analyzing your own apps, attempting to access data of apps you don't own carries significant legal, ethical, and technical risks. Always prioritize ethical behavior, respect privacy, and adhere to legal guidelines. Use the knowledge gained from this tutorial responsibly. Remember that game developers invest significant time and resources into creating their games, and it's important to respect their intellectual property and terms of service.